Vi väntar bara, det är inte en gå in och
det verkar vara jag har inte tillgång till något. Vi ska göra om ett kalender. Så vi behöver liksom se patienternas som vi kan skriva på boken. Jag har inte tillgång till det. Ja, det har ju fått att skriva om. Det är svårt att sätta sig in i det. Det är färdigt. Jag får lite tid att back to the drawing board. Ja.
Jag var där förra gången. Det var säkert en timme.
Det här är ju bra ställe. Vi har alla de här jobbar.
Det gör det. Det är bra att jag får på. Det är tvärtom.
Ja.
Symmetriskt eller symmetrisk chapter.
Happy to have do you have any Wi-Fi no, I'm thinking we should put it out for a person. Probably should share Wi-Fi.
We have this projector.
To whatever you're putting into. So if you have one slide, on the slide put up that now while I was waiting.
Is this HTML, right? This one, thinking that you can use this one, and then we have this one for Christina, who's just gonna present the, and she will, you'll basically just be Then we have the mute button. So it's currently mute. That should be live if you unmute it. You can try it if
You see that we one of our meetups is with subtitles. Yeah, because we had a meetup at SVT, they just gave it to their teams there. They subtitled the entire talk, No, we had a few. We had one at 0 X. Generally in summer it's pretty good. We're doing some pretty major reorganizations and changes to how the meetups run. So we want to there's issues that people relate to different ideas for events, and then you can look for links to the speakers one day if you want to speak. And everyone can be open, transparent for a while. And then people review the podcast and then once it's heard, you won't know. Yeah. I'm just thinking it's not me being a doctor because I'm so busy with things all the time, so it's always hard for me to dedicate time. I should probably dedicate that. So that's always been important to create a really good React community in Stockholm, like where people know each other, people can find help, and we can have like a little bit of podcast. We're planning now a TypeScript workshop. So from there, then they get code TypeScript, and we're going to do one round testing. So like the whole thing is just to make the Stockholm better. It should be a really good React community. And we're trying to get people to contribute back to open source and just meet them also. So I shouldn't be able to have everything should be open. Everyone should be able to create events. As long as the community wants that. So I'm not going to announce that today, but I'll say a few words. We have some changes coming, and then we'll set up the email in like a couple of weeks when we have everything structured the way we want it to. Because we're not two people merging each other's pull requests and trying to arrange it. So we've created ways that really structure it. So it's like 2 weeks away or something, and just launch it and see how people react. José, how do you want to be introduced? I'll take a photo of you for your middle of everything. Beautiful.
Yes. Okay. Nice. Nice. Super looking forward to it. Really nice. Yeah. Really like it. Yeah. I wasn't expecting so many people. Yeah. It's filled up pretty fast. Yeah. Hopefully the live stream works. Yeah, you know it was live stream. That's top pick. I've never seen that in any previous meetups. You have to get better. To get better. Have you shared the link to the live stream? I believe so, yeah. Okay. We're also recording it, so so I better do it right. There's no edits. No video company, but no edits. Okay. I read the blog post related to the topic. Yeah, it's going to be really exciting too. Yeah, I've been trying to condense it a bit. There's so much code. I've been trying to make it a bit shorter and more direct. Let's see how it goes. We won't be too boring. Yeah, it was nice to have a break. I thought we were going to show it here, and then it was going to be a bit difficult to go. I want
Röstning av musik. Så det kan vara så kul. Eller i och för sig, det är han som ska
Kristina, she from music Epidemic Sound. Hello everyone. Hello. Can everyone hear me? Can everyone hear me? Very nice, thank you. So yeah, just wanted to take a couple of seconds to thank everyone for showing up. It's great seeing all these new faces and some old ones as well. So I'm David. I started the React Stockholm Meetup a few years ago. I'm super excited to see that it's grown so much in the last couple of years. I won't be too long, but I just wanted to say that we have some really cool changes coming to the meetup and how it's organized. It involves a lot of open source, a lot of GitHub, so things that us as developers should like. So in a few weeks, we'll send out some emails, and I really hope that people feel welcome to contributing in any way, shape, or form. But we'll send out a few emails about what's coming in the future. So without further ado, I'll give it up to Christina from Epidemic Sound, head of music, and yeah, enjoy.
Thank you.
Hello. Good to see you. Warm welcome to Epidemic. I asked if how much time do I have to tell you about Epidemic, and I have 1 minute. So, do you know? Have you heard of? Just raise your hands. Do you know what Epidemic does? Okay. Shit. There's one, no, there's not. Okay, I thought I was gonna have one slide, but it's gone. Epidemic is a music company. We set out to serve storytellers with music so that they can tell better stories. But we also want to democratize the music industry. for giving creators an opportunity to actually live off their craft in a different way than by having your songs on Billboard Top 100. And I think we do just that. So the picture that might illustrates these two networks that actually coexist. So just imagine that you have our customers, the storytellers of the world, YouTubers, broadcasters, ad agencies, production companies that need music to tell stories. And then next to that, you have vocalists that create music for the use in audiovisual works. These two networks, thanks to what Epidemic has done the last 9 years, have actually created what we see as like the soundtracking of the internet. There's so many impressions today in YouTube, Facebook, where our music is involved. We think around 20 to 40 billion music in it. And this is, of course, strengthening our group of musicians that we work with. So that was what I wanted to show you, these two circles. But that's it. My time's up. So with no further ado, the guest of the hour is José from Spain, web developer, qualified. Now you can leave trying to find my PowerPoint and go back to yours. But welcome. I hope you enjoy. Thank you.
Hello. Yeah, sorry for that. I was looking for a picture, but I couldn't get it. So let's see. Yes. Maybe it changes the picture is going to be. What everything is going to be. Super tiny. Okay. Yes, so first of all, thank you very much for inviting me to be here. I wasn't expecting so many people, and I would really like to tell you a bit about how to achieve good performance working with React. But the idea is to focus a bit more on lazy loading and code splitting. So yeah, I'm Jose, and I work as an engineer in Spotify. And I really like building sites that are fast. And for a long time, I've been a bit scared about React. I think React is really great for developer ergonomics. But at the same time, we know that when we ship a big bundle, it can be a problem with performance, right? And in some applications, it might be that the code for the application is way smaller than the code that we ship for the library or the framework. So I've been always a bit skeptical about just using React for everything, because I always like to take into account user experience and the performance. So I'm working a lot on doing performance enhancement and trying to make sure that everything works without JavaScript. But in the end, I had to switch to something else. There are some great things about using React that really makes it shine. One of them is being able to create components and unit test them, and then forget about having to test the whole thing using browser tests. So being able to code a component, run some unit tests, and then pretty much forget about having to run so many browser tests. We've been switching to React pretty much across all the teams in Spotify. We were using Angular, we were using some homemade frameworks, and it was quite interesting because we don't have any obligation to use a certain library, so it's quite organic. But organically, everyone started using React at the same time, and we can find React pretty much across the whole company in different ways. So There's something about trying to use the latest thing that I don't know. I'm really scared about trying to use the most modern thing just because it's new. But when you see how you can use components and you can combine them with basics and being able to define dependencies clearly for the components, suddenly you have a way to really ship the code that you need for certain things, right? And then you start forgetting about shipping the whole library. You can ship smaller chunks that are needed for the page. So today I want to talk a bit about how we can create a component to do lazy loading, how we can apply the same component to other use cases. I will also talk about how to load polyfills on demand, and some existing implementations of these libraries. So the whole idea is to improve the performance of sites loading just what is needed. So on a regular page, we can find something like this, where we have a header that might contain a hero image, and we can have some pictures and a widget like a map, right? Most users accessing our pages are going to see the top. They are going to see the header, but they might not ever see the map below. So especially on mobile. So what's the point in loading all this content here if the user is never going to see it, right? So if there was a way to load this afterwards, only when it's needed, then we would be saving requests. And those requests are really competing with other requests that are more necessary. If loading this is going to delay more important code, like the code that we might need for a button there, that might be an important call to action, then it starts being super important. So in terms of React, if we think about components, we can have some components like the ones on the right side, like a header, some gallery, and a map, and something like that. So I'm going to be talking a bit about how to load these things in a lazy loading way. So back in the days, we had a way to define dependencies for a certain module. And if you've ever used YUI loader or require.js, you pretty much define a module and you said, I'm depending on these other modules. And then behind the scenes, it will try to load those dependencies before executing your code. Right? That's ancient now. We have ES6 and we have dynamic import. And we can use bundlers like Parcel or Webpack to create different bundles. So those dynamic imports will be split and a different bundle will be created. Then we have had lazy loading or lazy loading techniques for a long time. We had to manually implement them using listeners that would listen to all the scroll events and the resize events on the screen. So every time there was a change in the scroll or the width of the screen, you will need to go through all the elements that are going to be lazy loaded, then figure out the positions and seeing if their position is overlapping with the current viewport. So that was very time consuming, and in some cases it was even bad for performance. If you didn't throttle these calculations, then suddenly you had lots of stuttering when trying to scroll. So it was backfiring. These days we have something better, which is called intersectional server, that I'm going also to describe. But the idea is that you listen to, you monitor a certain div, a certain element, and then you will get events when that element makes it to the viewport. That's exactly what we want. We don't want to listen to all scroll and resize and then going through all the possible lazy loading elements. So lazy loading is great for performance, but lazy loading, as with everything in engineering, it has its trade-offs. Whenever someone tells you that this is the best thing ever, they are hiding something. So I said, this content is pretty much going to always be seen by the user. So there's nothing lazy loading that, right? Unless there's some link where you use a hashtag and then the user lands on some section here, which doesn't usually happen. The user is always going to see this. If you apply lazy loading to that, you are only going to delay the loading of the whole thing, right? It won't be rendered on the server. It will use some JavaScript that will need to figure out if that element is there. So it's going to be delaying the critical part. Then when we lazy load, we are going to have issues with content that won't appear until a few seconds later. So here, if we have this report, if we scroll down and we wait until these images are within the viewport, then the user will see some blank areas here, right? So it might be a good idea to start loading content that is not within the viewport yet, but is close enough. You don't want the user to scroll and then see a blank page. The user needs to have some feedback about what's going on. And then when you lazy load, you can also have some issues if the user is going to print the page. Okay, it doesn't happen often, but it's something to take into account. Also, if you are working on, so if you are applying it to a blog and the user is reading your blog through an RSS reader, it might use that content is unloaded. And I was also doing some checks, and Google doesn't index most of the lazy loaded content. There are some events that are not going to be triggered. So the crawler does execute JavaScript. It does see the whole page, but it doesn't trigger all those events or the observing while the user is scrolling. So that's something to take into account if you are going to apply lazy loading. So now let's look at the code. Let's try to implement a component that is going to detect when certain error is visible. So for this, we are going to be using compositional patterns. Most of you already know about higher components and things like Redux. But the idea is that in React, everything is a component, and you can have components that get another component as the parameter, and then they attach some behavior. So you don't necessarily need to have components that are going to render UI elements. You can have technique skins. You can have components that will apply some behavior. This is code that is taken from Redux. So this connect function is going to apply. It's going to take basically this component and it's going to make sure that it knows when the store gets an update. So this component that it was a stateless component, and you didn't know anything about the side is going to be getting those dependency chains in the store. Similarly, we can have another pattern that is called function as type component or render callback. This is taken from a library that is called React Media, and the idea is that you can have a component that displays in a different way depending on the media query. And for that, you define a media, and then you get a parameter, and using that parameter, you can decide what to do with it. So it's another easy way to have functionality without having to embed all this logic within my component. So following this, we can have a component that is going to know when it's visible. So this is the whole component I'm going to be zooming in on the things that are important. So let's say that we want the map or the gallery to be lazy loaded. We can wrap it on this component, and the component is going to have a div wrapping that section. And using that div, we're going to pass it to the intersection observer. So whenever that div intersects with the viewport, we are going to say that it's visible. And then we pass the invisible to the children. This is how we disconnect it. Here, pass that is visible to the component, so the component that will. So it's a component that will tell its children, now you're visible. And using the lifecycle events from React, we can also disconnect the intersection observer, which is a really good thing to avoid having memory leaks. Then the way we can use it is we can have the header that we always want to render, and then we can have that gallery in the map receiving is visible when they are visible. And then it's up to them to define what they want to do. So the gallery can do something like this. It can make it visible, and then if it's visible, it loads the image. If it doesn't, if it's not visible, then it renders in placeholder. The problem with this pattern is that the moment it becomes invisible, then it's going to render placeholder. If it becomes visible again, then it's going to render the image again. We need to make sure that that image has the proper task headers. Otherwise, we are going to be making requests every time it makes it to the viewport. Then another problem I see quite often is when we lazy load components, we don't reserve the area for the components. So this placeholder, it needs to have the same size as the image, otherwise it's going to be collapsed. The content will be wrong. You've probably seen that browsing sites. That suddenly you're in a certain scroll position and then everything starts moving as the web as browser downloads the images. Then we can use the same component to grab the map. And in this case, we grab again the container with that div. And then what we do here is that whenever it gets visible, then we initialize the map. And here we are going to load the script for a Google map. So again, the idea is that I don't need to load the script no matter what. Now I can load it whenever that content is on the screen. And I can also put a certain dependency. So if my page doesn't have any Google map, then I don't need to load it at all. Right? So we delay the loading of these third-party scripts to the moment they are needed. And it's not only a script, it's also all the assets that they are going to be downloading through that script. These components that track the visible state can become a bit too cumbersome. It has lots of boilerplate. Here we don't want to load the state twice, so I'm storing the state whether the component needs initialized or not. A different way we can do it is moving the state up to the server. So we can have something like it's visible, but also it has been visible. So this one will always be true if it's been visible at least once. So instead of keeping track of the state within the children, we can just move it. So whenever you can use a stateless component, it's a good idea to use a stateless component instead of having to track this state everywhere. So this component that tracks the visibility, we use it for lazy loading. We can also use it for other use cases. And this is a website that I was browsing recently. It has these animations that start whenever you see the section. Right? So again, here we only care about the fact that this section makes it to the view. And this is the code for that component. So here we track it. If it wasn't visible and now it's visible, and the animation hasn't started yet, then we start the animation. And that's going to render some data. I've been talking about how to use intersection observer, but I didn't mention that it's not supported everywhere. It's something that Google started with on their own, and some other browsers have followed, like Firefox, but it's still not supported on Safari. So when we have one of these issues, the natural solution is to add a polyfill. And we add a polyfill, and then that's solved. But then if the user is using Chrome, or if they are using a browser that supports these APIs, why do they need to load the polyfill? Why are we penalizing users that are using modern browsers? So a better way is to, since we are talking a bit about lazy loading content and making sure that we only load what we need, we can do the same thing with the polyfill. So there are two solutions here. The MVP, absolutely MVP, we can say, okay, if we don't have support for an exceptional server, we are going to assume that the content is visible, right? So it's a bit of like progressive enhancement. If we have something to lazy load, then we are lazy. Otherwise, it always goes. So here we state, in the state we set is visible to the content of the presence of index on server. So if we don't have index on server, then it's visible. Then another solution which I prefer is to load the polyfill. We can do something like this where we check for the presence of indexation on server. If we have it, then we restore it. Otherwise, we import that polyfill. And we wrap it like if it was a promise. And here we execute the code, already knowing that we have that loaded. And the great thing about this is that tools like I said, like Parser and Webpack, they are going to take this import to a different bundle. So in practice, this looks like this. This is Safari, and it doesn't support the section server. So here we are going to get an extra request for the polyfill. So it's a very easy way to load polyfills on demand. And you can see that the code is quite simple, and there's no real reason to be loading it no matter what. It's not huge, this polyfill, but yeah, it's 20 kilobytes. So I think most of the times I've been talking about JavaScript and about images, but the great thing is that you can also combine this with CSS. So if you've ever used React Router, you have code splitting already at the path level. So you can load only the code that is needed for a certain path. If you have used Next.js, it's pretty much the same. And lazy loading can be applied to SVGs and CSS. So imagine that you have that section that you want to lazy load. If you were using CSS in JavaScript, then the CSS code will be written in JavaScript. So if we are lazy loading the JavaScript, we are also lazy loading the CSS. So suddenly something that looks like, oh, modern, oh, great, only the cool guys are using it, now it becomes something super useful. Because there wasn't any good way to do lazy loading of CSS. Right? If you lazy load a style sheet, chances are that your content is going to be restyled and things will change if you are not careful. But in this case, we can lazy load the CSS also together with the rest of the JavaScript code. So it's a very easy and convenient way of splitting both the JavaScript and the CSS. So again, you can combine all these tools that in isolation, they look like, yeah, it's modern, and I would like to try it out. But if you combine all of them, you can achieve really performant sites without thinking about the penalization of having to load a big library. So I've been talking about this observer component. There are a couple of libraries that also implement this component, and they track more things. They support all the different options that you can pass to the intersection of server. So they are really useful if you want to apply lazy loading, or if you want to detect that a certain element is in the screen. So yeah, as I said, the conclusion is that if you create components, it's great because you can build sites using smaller pieces, but at the same time, you can really decide what you need to load at any point. And it's easier than ever. And you can take all these buzzwords and then put them together and still build high-performance sites. So again, I've been always super scared about jumping on the latest library just because it was new. And they have usually had a very bad impact on user performance. So it was great for developers, but you knew there was going to be some fallback, some trade-off there, and users would suffer. In this case, we can combine all of this. And all the code that I've been showing, you can also run with Preact. So if you really care about performance and about small footprint, you can use Preact, and then you have pretty much super performance site using components and using all the latest tools. So that was my talk. If you care about performance, I tweet from time to time on that handle, and I've been also working about performance and React and all of this on my website. So thank you very much. I don't know if there's time for questions while there's one prepared.
Yeah, so if anyone has a question, they might want to reach back over there, but maybe you want to come forward and ask a question.
One of the images you were using higher order components.
Yes.
I wonder why that over render
No, it was, the idea was to show different, like 2 different ways that we can create more complex components without having to pollute a certain component. Like, I want to make sure that I can decouple a certain behavior that I can be used on different components. How can I apply that behavior? So you can pretty much use any of those. There are also some libraries like React Router that have been using one of them and then they move to the other one. So in reality, they both allow for the same solution. It's a bit of, there might be some minor nuances.
Any other questions?
The code splitting, can you relate it to microservices or something?
To microservices?
Yeah.
You
said code splitting.
Yeah. So, do you want me to explain code splitting, or because it's not really related with microservices?
Then you can explain the code splitting argument.
Okay. So the idea is that these days we are building lots of single-page applications, right? And it's very easy by default to generate a big bundle with all the code for the website. But it doesn't make sense that if you add 10 more pages to your website, your JavaScript bundle shouldn't be bigger than before. Like if you access the home page, it shouldn't matter that you're adding 20 more pages to the site. But in practice, if you put everything in one file, in one bundle, then as the site grows, your bundle also grows. You have all the JavaScript code there, all the React code. So code splitting, what the idea is, instead of loading a big bundle, which means in practice that the user sees an empty page, and then the browser has to download all this big bundle. It has to parse it, it has to execute it, and then finally it will take pretty much a small section of that is needed for rendering the home page. Instead of doing that, you get the code that you need for rendering the home page, not the code for the whole site. So it's a way to avoid written a big bundle with JavaScript file.
No more questions? Great. Thank you very much, Jose. And we will have a quick break. So mingle around, take some pizza, snacks, beer, just more beer.
I was running, so I've been thinking about what Google does and the things that they use it quite old logos workaround is, I think the important thing is that whatever it is, this shouldn't be for normally after the lock. Yeah, but the broadcast side is full. After the there is an app, there is a notification after the lock. We can do this kind of things after the do we have any workaround? Yeah, not really. Whatever it is, imagine that in your case, it's quite likely that they are not going to see. So it's a trade-off. I know that some people are complaining who are old, now maybe people used to do creating like a server side and then service side really, I don't know what they are using about it. We use PHP. We have GraphQL. Right. Browser resonates with REST API. The API is a access for
we going on first?
At least that's what the schedule said. That's why I assumed.
We're thinking of like 40 minutes break is way too long. So
40.
yeah, that's what the schedule says. So we're probably just gonna have like 50 minutes or something.
Sounds good.
Great help. If you attach this like here, as close to the mouth as possible. And then you can have this in your back pocket. And you have the mute button, so it's currently muted, but to unmute it, you just do that. I go and put it, you can mute it on the mixer as well.
But now it's muted.
It's muted now. Yeah.
That would mean this one.
Yeah.
Cool.
First time loading too fast. Yeah, but you don't want to have buttons, and then the user, they don't see a button. So that's the end of the user, which I read and like, oh, it's so fast. But none of the buttons is working. Yeah, so that's why something we started pushing for in the internet. And now there's lots of people saying that maybe we need to also making the conversation, making the we have to
Spotify is still
first people that think Spotify start roads,
Facebook is using it. There is no value to make yourself such a
if you like JavaScript, you like to get maybe
Don't join Spotify.
no, actually there are things that are pushing for creators. A couple of years ago, some people would say, no, we don't push anything. And today, we have people trying out yeah, we can use the some very convenient
No value to the user.
Nobody to the user. I think that's what you want to
But within after 10 years, used to be Spotify has to change.
Whenever you want to go into your picture, maybe you can import parts of the class. You can import it we are working with that. Now we have a run some scripts to provide When I gave it to you,
Are you using Redux as are you using React with Redux?
where is React? Basically, using Mobile. Some people are also looking to
Stack is like React, Redux, PHP, React Router.
Again, there are things that are API, so the kind of thing normally
Where's PHP?
PHP you want to
What's the extension? PHP.
services are made in Java.
Tell the routing. Routing. The example I got. The directive to smash routing. This is PHP routing or this is React routing.
Normally it's I think it's I'm going to Python, Java,
You're working in Stockholm. You have backend
some service so basically, if you need data for different services, instead of making a language, maybe you want to do like one. And then the back end will be something that makes it very swift together. Makes it
It's good for users because user is just having one account.
So most of the is mobile is
Take time. Server can take some time.
yeah, on the server, all the machines are co-located on the same server, so hopefully it doesn't need to go to the internet. Hopefully something that goes on the so it's going to take some time. But if you don't make them to the server, that's having to go make the user go to their closest server.
How the CDN works. It's like saying,
Yeah.
go to like Singapore maybe. Washington.
Yeah, because we are super worried about the performance. We are we have opened the development Costa Rica, because now we have Asia, we need to yeah, we are able to carry iPhones every someone in Malaysia, they have a problem.
Just one question asked. How big is the browser implementation? You check all the features of all the browsers if user comes back not using high time, I'm not sure.
Yeah, we need to make it for we need to say have 1% of users but not they can have long time all that, then it's also going to have an impact on the user process because we are adding lots of policies and we also need to get every time we see something
Flash is still there.
Now we use standard.
It's still fine.
That's not what we that's why but everyone is using I think it's probably in every company.
Yeah.
How do you make sure that you have a great experience for all the browsers? If you are using
It depends on how many users are on a particular browser. If I have like 90% on the top 3 that are also
as a developer, normally you don't test all the browsers. You also automate Somebody will say, okay, we have 65 for one house, and we know that we're going to be able to
Please subscribe us.
Everyone.
Maybe we need to put on
On the near talking, sorry, I give more slides. Okay, what are you going to talk about? So that's like yeah, okay.
So it's a lightning talk. It's not very long. It's like
how is yours different from this?
this is about taking your bundle, your JavaScript bundle, splitting it up. Mine is it's about what's in the bundle. So the component is
Basically, whatever that comes with
any version of React, like just the React library.
I just have to.
Should I
All right. So we will have a few lightning talks starting Justin. Yeah, basically. So Abenezer will hold the first one.
Hi everyone, welcome. It's great to have everybody here. My name is Abenezer. I'm a software developer here at Epidemic Sound. And today I'm going to be talking to you about a class in the React library called PureComponent. You might have heard about it before. And before I get into what PureComponent does, I just want to raise a question, and that is, should component update? Always. So I made a little demo here to sort of demonstrate and answer that question. So this demo here basically takes an input, it's a message, and then the message gets rendered into a list of messages here that shows the history of the message. So as I type here, you see the history of my message. And every single one of these beige lines, that's a component called message, and it's rendered in a message list. Now, the interesting thing is that as I'm updating this history, should these already rendered components update? I mean, they're not changing their values, right? So should they update? And to answer that question, I'm going to open up the React DevTools in Chrome. And I'm going to toggle this highlight updates here. And what this is basically going to do is it's going to show us how often a component is re-rendering or updating. And it's data visualization, so it shows you in colors. So it goes on a spectrum from like light blue, where you're updating every so often and everything's cool, to extremely red, where you're updating a lot and it's just like, please stop doing that. So now I've toggled that on. I'm going to clear, and I'm going to start again. What do we see there? A lot of red on the visualization of re-rendering on the left side. But did you notice on the right side? Not so much. So the question is, why does this happen? Why are these components re-rendering so often? I promise I haven't done something super bizarre to them. And the point of this is we use React because we want to build dynamic applications. We want our components to update when our data updates. And React components have sort of two sources of data. That's your props and your state. And the truth is, when your state changes, your component updates. When your props change, your component updates. And it's quite easy to see when your state changes that your component updates, because you explicitly call set state, and you expect things to happen after that. But the question is, how does a component know when its props change? It doesn't really care to ask. It's got a very naive answer, and that is anytime a component's parent updates, a component believes that its props have changed, whether they actually have or not. And the reason is because in the lifecycle method of a component, after it's initially mounted and everything, it asks this question: should component update? And by default, a React component returns true. That's what it does. So here, my normal component, as I'm typing, it just expects that it's always going to have to update. And if I show you the code here, this is my message list. Here's my normal component. It's a message. And in the message, all I have is a render method, and I just render a list item. But what if I answer the should component update differently? What if I check for my next props, and I say, are the props that are coming in different from the props that I already have? And if they are, then true, please update. If they're not, then leave me alone. So now that I've made that change, we expect that the components that have already rendered in the history of the message are not going to turn red. That's the expectation. And I forgot to update this React DevTools. Here we go. And now we should see some color again. And just by changing 3 lines of code, now you see a lot less red going on in my normal component. But what you also notice is that it visualizes the exact same way as my pure component that's on the right. So the truth of the matter, the fact of the matter is that a pure component is a class in the React library that itself extends the React component class, and itself applies the should component update method for us. And if I show you in the code here, so this is my regular React component, and here is my pure component. And all it calls is render, because the React pure component applies the should component update check for us. That's it, that's the magic. And of course, like Jose said, with everything that's awesome, there's some drawbacks. And some of the things with this is that in the word itself, pure component, you basically agree that your component is only going to be a function of props or state, and that there's not going to be any side effects. Because if there are, they're going to be ignored and you're not going to get the result that you expect. Also, if you pass props that are deeply nested objects or deeply nested arrays, they're also not going to return the result that you expect. And last but not least, if my pure message component was to render further children components, they would also be affected by this because the pure message component is not going to re-render. I'll take your question in a few seconds. So you have to be aware that when you're transforming a component to a pure component, or you're applying should component update on a component, it's a lot of components, that you take into account the other children components that that component renders as well, so that you don't isolate them. That's basically pure component. Yes?
If you go back to the code thing.
Yep.
You talked about deep objects. What about if I extend from, thank you. What about if I extend from React component and actually implement that should component update properly, so that it takes care of deep component inspection, then should update properly to the deep object, right?
Absolutely. So that actually is something that I'm happy that you raised, because I think these negative side effects that people say about pure components are actually things that force us to be better programmers. Because you could either apply should component update yourself and check exactly for the deeply nested objects, or you could also just not transform your objects, but create new ones, sort of like what Redux tells us to do. And with that, what happens is the reference for your object actually does change because you're creating a new object. So then should component update will tell the truth as well. So you can either apply specifically and check specifically for the deeply nested object, or you could also not transform your objects and your arrays, but create new ones, as you should in functional programming. Another thing also to mention with this is if you bind functions in the render method, every time render is called, you're creating new functions. So that's also going to affect that if you're passing it down as a prop. So yes, you can either apply it yourself, or you can bind things in the class, not in the render, but as a method, and also not transform your arrays and objects. Any other questions? Did you like my colors?
Yes, would the stateless component re-render all the time also, or would that solve it?
That's a great question. So a stateless component is just a React component that is a render method. So yes, it will. And the thing to know with this is not always, it's not a magic bullet. You don't always have to do this. The naivety of the React component is okay most of the time. But if you have something, for example, us being a music company, on our website, we have a music player, and we have a set interval that makes sure that re-renders every so often so that it updates. And anytime you have a set interval or something like that, that's going to set state every X number of milliseconds. For example, if you're a game company or you're rendering animations, then you should really care. Because then these updates become so frequent. And then if that update is affecting things that shouldn't be affected, like history that's already done, that's when you see a lot of the optimizations. So don't transform all your components into pure components. Look at places where that could make a big impact for you. Great, thank you very much.
Mute it while we switch.
Great.
Yeah, really. You can stand on my shoulders. Oh, yeah.
Borrow your
I don't know if people still need the Wi-Fi.
It doesn't make sense. Tar du igen och så nära. Eller vill du se runt om så nära? Alltså de är så runt. Är den på eller? Okej, men den är mutad. Men jag
All right, thank you for that talk, Abenezer. Next up is Johan Bjurling.
That's right. You hear me? Yeah? Great. So yeah, my name is Johan. I'm also a developer here at Academic Sound. And today's topic is speeding things up in React. And we've heard Jose talk about like one of these strategies, which is basically like loading less stuff, postponing loading of the stuff until later when you need it, if you need it. And I think most of you know about other strategies such as, concatenating files to make fewer requests and minimizing them to make them smaller. So that's like one side of optimization. And now we heard Abenezer talk about the stuff that's going on inside the browser, optimizing their actual rendering. What I'm going to talk about is another domain of optimization, basically like what's going on the network. Because even though you load less stuff, eventually you're going to have to load some stuff. And then we want to make sure that that stuff loads as fast as possible. And I'm also going to talk about how the solution I will show you, how it relates to us as React developers. So I'm working with one of our products, one of our brands, which is called Soundry. It's quite a new one. Soundry is an application that is directed towards like small and medium-sized businesses such as cafes, restaurants, barbershops, hairdressers, spas, and gyms and such, who want to play background music in their public space, basically. So that's Soundry, and why don't I show you just like the widgets? So here we are, we're logged in, and you have a bunch of channels categorized for different moods, like soft and smooth or energy boost. So we can click play and see if the sound is up. Simple as that. So it's a fairly trivial web application, meaning it's actually serverless. It's a static website. So I'm going to show you basically the zoomed out architecture of Soundry. What we have is this web client that I just showed you, which is React JS Redux single page application. We also have an iOS client, an iOS app built in React Native. So we have been able to copy quite a lot of code from the web client to the iOS client, which has been handy. They are both powered by a backend API, but that's not really part of like the client. The client is merely a JavaScript bundle. The backend API is like a REST API where you can like request JSON files with the channels and URLs to our songs. Behind that, we have a payment and subscription engine, which is powered by an external PSP provider. And this is all built using AWS services. And I'm going to run through real quickly the vast number of AWS services that we use. We use S3 for storing our static files. I'll get back to that later. We use Cloudfront to distribute our static website worldwide. So Cloudfront is AWS's CDN that has edge locations around the globe, which moves our content closer to our end users. We use Route 53 for domain name management. We use Cognito for user authentication, VPC for network security, IAM for everything related to who can do what, identity and access management, that is. ECS for containerization, so our backend and our payment service is running as Docker containers. CloudWatch, which is coupled to S3 for logging and monitoring. RDS for our databases. We use SQS for our message queue for when to make payments, for instance. We use Lambda for customizing email templates and sending Slack notifications if something happens in our application. And we use SNS for sending alarms. So as you see, we like really utilize Amazon a lot. But I want to talk about these three, because these three are the ones that are mostly connected to our React web app. So I'm just going to go into slightly more detail. So S3 stands for Simple Storage Service. In S3, you basically upload files of any kind, and they're put in what they call buckets. So in a bucket, you can have, like we have all our audio files there, for instance, but also our application bundle we upload to S3. And the nice thing with S3 is that it has a lot of functionality that you can like sprinkle on top of your files. So you can add logging to track what's going on with your files. You can add encryption if you want. You can add permission management, so you can make your files public if you want. You can set up cross-origin resource sharing configuration, so that you like, which is very handy when it comes in the end when the stuff lands in our web clients. And you can actually like host a static website here. So on top of S3, we have CloudFront that I spoke about. It's basically what it says: a service for speeding up the distribution of static and dynamic web content by pushing it to edge locations around the globe. So basically, when a user requests a file, if the content exists in the edge location, which could be like some on the American West Coast, then the edge location will serve it directly. So the distance our files need to travel is vastly shortened. So basically, this is how we speed up the delivery phase of the whole process of loading and executing a file. If the content does not exist in the edge location, CloudFront will fetch it from its origin, which is S3, and cache it. So CloudFront enables cache and header configuration. So here we can really fine-tune like our headers and what headers we want to send through down to S3 and for how long we want to cache the stuff. So what CloudFront, it's really CloudFront that is the magic here for speeding up our web application on the network. Another nifty thing is it adds additional features such as geo-blocking, which is something we use because we want to make sure Soundry is delivered to all of the world except US. So we can actually like say not US, and we could say like these parts of the world cannot use Soundry. And then we have Route 53, which is basically a domain name service. You can register domain names. You route internet traffic for a domain to a corresponding resource, and you can, if you want to, do health checking. So I'm going to show you like the flow when our web client, our React app, wants to look up www.soundry.com. It goes to Route 53, which will direct our request to our CloudFront distribution, which will, if it has the file we're requesting, can respond immediately. If it doesn't, it will go to S3, our static website, which will then return it all the way up. And the nice thing with this is deploying our web application is super simple, because it's basically like building our bundle our app and then pushing it to S3. And that we do using the AWS command line interface, which is a command line tool. So we basically push a new build to S3 from our local dev environment. And in the process, we also set cache control headers for all our files except for index.html. And we set it to cache control public, max age, and that long number is the number of seconds in a year. So basically, we're telling S3, like, this can be cached for forever, virtually, except index.html. For index.html, we say this can be cached, the max age of this file is 60 seconds. Because in index.html, that's the only file that you actually need to load, like initially, to bootstrap the application. It's like the main function, if you will. And it's basically, like you all know, like an empty page with just a reference to script. But in that index file, we have like the version number pointing to the correct version, which is basically a subfolder in S3 that holds the latest app build. So that's why, like, we want to set as long a cache time as possible on all our assets except the index file. But in this process, we also send an invalidation request to CloudFront for the index file to speed up the invalidation of the cache as much as possible. So this is all good. We get great speed. We can set our headers. We can like configure a course in S3. We can do geo-blocking. It's like a really, really nice setup to make a blazingly fast web application. So what's the catch? Well, the problem is when you combine this with React, you run into problems because this setup is basically following the old-fashioned web paradigm. What do I mean by that? Well, we are requesting actual resources, and all our URLs. You go to sounder.com. Well, sorry. If you go to sounder.com, that's going to work fine. But when combining this old-fashioned web paradigm with React Router, we run into the problem because React Router, its routing, its paths belong in the React application. They don't mean anything in like a folder structure that we have set up on S3. In fact, on S3, there is merely one single path to follow. It's to the root. Then you load the app.js and bootstrap the application, and every route from then on is only concerned with the application, the React application. So if you go to sounder.com, fine. It works like the way I showed you. But what if you go to this URL, which you might well do? I mean, we want to provide deep linking. We want to be able to create landing pages, and we want to be able for users to like bookmark our browse page, or if we add an album page, we want them to bookmark that. We want Google to be able to index our pages in a good fashion. So, but if I would go to this URL, I would get this. Because the page does not exist. The only page that exists in S3 is the root. So what do we have to do? Well, we need to do a hack to make this work in React. And here, once again, CloudFront comes to our rescue. Because in CloudFront, you can set up custom error responses. So this, I admit this is a tad ugly, but we set up when CloudFront goes to S3 and gets a 404 or a 403 back, we basically say, well, never mind. Serve an index page with a 200 response code. Ta-da! And then everything works. So there is one disadvantage to this stuff. You can never both have the cake and eat it, you know? So the disadvantage here is we go to this URL. What will happen? It's okay. So you don't get a proper 404 response. You will always get a 200 OK back, which is like, in the best of worlds, you would have wanted this 404 page here. But I mean, what the heck? So that's basically how to like use AWS and these services I showed you to serve blazingly fast web applications and use React at the same time.
Just wondering about that. Isn't there a path filter somewhere? Isn't there some Amazon servers which you could do firewall filtering based on URLs to solve that?
It might be.
Because we have similar stuff in Azure.
Okay, yeah. We've been looking into like trying to do some clever URL rewrites, because in S3 you can set up actually like redirection rules. You can configure, like set up an XML configuration, but the problem is it's always, from what I've found, it always just like redirects you, and that's not what we want. We want like deep linking. So if there would be some similar to what you can do in Apache, where you can actually do rewrites, like interpret different rules differently, that would be awesome.
There should be.
Okay.
I'm pretty sure they're in like the tons of services in AWS. There should be.
Oh yeah. If you know like if you have something on your mind, let me know later. But I've been looking quite a lot into it and spent some hours googling it. Yes, please.
Can you not set up a 404 handling in React Router for apps that don't exist?
Absolutely. That's absolutely for sure. That's what we do. Yeah. So on top of this, we have, because internally in the like single page application, we want to tell the user like, now you entered a bad URL. So, but since you're only in the browser, you can never like change the HTTP response code. So this is only like the problem here is only when you do deep linking and when you go directly to something other than the root.
What about putting a proxy between a server-side proxy? I'm not sure what the AWS service is called, but there should be one.
Might be. I can't like. It might be a possible solution. I'm not sure. That wouldn't. Yeah, maybe it's a good idea.
Because, I mean, I'm not sure what it would do to your scaling, but if you put a proxy and you have whitelisted URLs, the proxy lets through, and everything else doesn't.
Yeah, we might look into it for sure.
So what's the drawback in practice of not responding with a 404 except that it is not correct?
Yes, exactly. I don't. They're very like, it's basically like a search engine might index. A search engine might index like a non-existing file as an existing file. I think that's like a very, very small problem, because no one would ever find this file anyway, because it's not going to get a good page rank. So it might be in Google, it's like this page exists. Okay, but the only one who knows about it is Google. So we really don't care about that.
You could solve that. You could solve that by explicitly whitelisting URLs in Google.
Yeah, I mean, you have so many suggestions here. I love it. All right, we have one more question.
Yeah, you mentioned that AWS service is fast, and I wonder, like, the request time. I want to know why it's so fast. Is it because we have server nearby or close to the region?
Exactly, that's the whole point with CloudFront. So CloudFront is a CDN, content delivery network, which means they have what they call edge locations around the world, like in America, a couple of them, in Europe, in Asia, and they're like opening up new ones all the time. And so basically, it's a matter of physically moving the files in the user's proximity. Because to skip a couple of hops and actually just to make the probability to avoid like bottlenecks bigger. And so that's one reason, like to actually physically move them. But then of course, CloudFront is really smart in setting up proper cache headers, because having like your headers on your files and on your resources in order is probably one of the absolutely biggest performance optimizations you should look into. I mean, like I said, reducing the file size and optimizing in the web browser are absolutely things to do to optimize. But if your cache headers aren't in place, you haven't done 80% of the work. So you should always start like setting up your network configuration and what's going on like out there before looking into pure components. Sorry, it's actually two different things. So.
Yeah, but that's what I'm thinking, because Amazon and Azure and Google's caching, scaling, whatever you call it, is about 1,000 times more efficient than we could ever think of in a small company. So if you actually do that correctly, correct me if I'm wrong, but it doesn't matter how big your file is as long as it's not too bloated. The infrastructure caching will beat the crap out of whatever optimization you can do on the app level.
Yeah, sure. Then of course, like if you serve a really big file, you're gonna add on the execution time as well. So there are like it's basically different things you're optimizing. It's optimizing the delivery, like you can call it time to first byte in a sense, like the network, and then you have the next level is like parsing and executing this, which also like a big file will add to the execution time and memory consumption, I guess. And then you have like the next step is like, okay, do you want to have a sluggish or a snappy application? Then that's where pure components comes into. So it's actually like you have to do all of it to really get a good application. Okay, so that was the final speech for tonight.
Thank you very much. Johan. And thank you so much for coming. There is more beer, there is wine if you want. Yeah, thanks for coming. Of course, we are recruiting. There's a link on the TV. And if we've been taking some photos. If you wish to not be in the photos, please hit us up, and please hit us, please. And of course, we will remove them. Thank you.